Alright, practical talks. What we know about phosphorus in Lake Erie. So let's recap with Laura. First question, Laura, is why is phosphorus such a big deal when we hear about harmful algal blooms in Lake Erie?
Well, thanks, Brett. What we've learned from phosphorus is that is what's driving the size of the blooms. It's what we call as a limiting nutrient. So when you think about what can feed the growth of algae, it's the same as the growth of plants, and phosphorus plays a key role in that. Other factors are important when it comes to blooms. We know nitrogen plays a role. We know sunlight, temperature, those are all important. But from all of these studies that we've had, it's phosphorus that's the primary driving factor of whether we're going to get a big bloom or not.
Okay. You mentioned nitrogen. What's the impact of nitrogen on that bloom?
Well, right now, early evidence is showing that nitrogen might be dictating how toxic the bloom might be, how many toxins they're producing. But we're still at the early stages of that research. It seems like different forms of nitrogen might have different impacts. For instance, this year we did not have nearly as many toxins as what we've had in past years.
Okay, very good. How do we know where the phosphorus in the lake is coming from, farm fields?
Well, that's kind of a tricky, the tricky answer, because there's a lot of different sources of phosphorus to the lake. It can come from agriculture, it can come from urban sources, it can come from our failing septic tanks, our sewage treatment plants. But when we look at the data, what we're finding is that the concentrations, they tend to increase when we see flows increase. When it rains, we see the rivers go up, concentrations go up, and that is a key factor of non-point sources, land runoff. So if it rains, that water will interact with the soil, pick up phosphorus, and deliver it to the river. And we only see that in this situation. Now when we look at our smaller and smaller watersheds that are more and more agriculture, we still see the same patterns of increasing dissolved phosphorus over time. We still see these patterns of increasing concentrations with storms. And so that implies that it seems like it's agriculture that's really driving this. Now we have some other researchers that are doing edge of field research, like Kevin King, and there you can also show that we see phosphorus coming out of tile drains and off the surface that are contributing to the ditches that get to streams, which gets to rivers, and then ultimately to the lake.
Okay. And so the point source is much more stable in the way the discharge come from that?
Right, yeah. Point sources come in pretty much the same amount every day because we're always using water in one way or another. And so that comes in pretty much exactly the same. If we have a storm, we have a greater volume of water in the river, it dilutes that same source rather than going up.
Okay, very good. Let's see if we have another question from our audience here. What are the questions are scientists trying to research to learn more about the P and the lake?
Well, what questions are we not trying to research? There's pretty much everything that we have questions about. If we think about specific to agriculture, we're still trying to figure out exactly why dissolved phosphorus has been increasing. We have a lot of ideas from, accumulation of phosphorus on the surface of soils to various types of land management techniques, macropore development and water going into the tiles and coming out. But we also have questions about changes in the chemistry of rainfall. What role does that play? What is soil compaction going to do? And what exact best management practices are going to get to the reductions that are being called for in order to not have algal blooms in the lake? We have lots of questions within the lake itself, going back to how important is nitrogen in dictating the toxicity of the blooms. If that's the case, maybe we need to think about not just phosphorus, but also nitrogen from the land. Mm-hmm. And how much phosphorus is really coming from our combined sewer overflows or from these different municipalities. And septic tanks. Failing septics are also a huge issue in our region. Are they contributing to this, and are we overlooking something there? So there's just tons of things that we can look into on that.
Okay, thank you, Laura, very much.